Hey everyone, this is Caleb with HVACschool.com, and I am here with Hunter Collins from KALOS Services, and we are here on the second video in our three-part series on testing the quality of Bluon tech support. Again, if you've been accredited through the app, you have access to their training materials as well as their equipment info and product data for a library of equipment, and you're also going to get access to the 24/7, 365 Bluon tech support line. These guys do not have access to the questions that we're asking beforehand. This is a completely organic service call, and this is going to be the second video in our three-part series. Hope you guys enjoy. Okay, so this second call, this is going to be regarding a low voltage short. It is blowing the fuse. So let's say we've got a 3 amp fuse on a circuit, on a low voltage circuit, and we are we're amping out high on the yellow wire, so the contactor wire going to the contactor. The contactor is not actually ever pulling in, it's just tripping automatically. But without a call, it's perfectly fine. We've visually inspected everything, nothing seems off, no loose connections, everything is good. Immediately blows the fuse as soon as we reset that and we get a call for cooling or for heating. We've tested all the other components, we know that we've narrowed it down to the Y circuit, and just spoiler alert, the issue here is we have a shunted contactor coil. So basically, if you ohmed out that contactor coil, you would read really low resistance. What happens is doesn't have enough resistance, so the amperage goes up and you end up with a blown fuse. You have to keep in mind that just ohming out a regular contactor without reference to a good contactor, that can be problematic, because then you don't know what it should read to begin with, and it's an inductive load, so it's going to change with the occurrence of reactive power. If it's reading really low resistance to begin with, then you're not even going to be able to make it to the closed contactor. It's going to completely blow the fuse because of overamping. And that's what we are discovering here on this particular call. The guy that we're about to call has absolutely no idea about this issue, so we're going to kind of test his knowledge on low voltage circuits and troubleshooting a low voltage short. Here we go.
Hey Mike, this is Hunter with KALOS Services. Good. How are you doing?
How you doing?
Good, how are you?
I'm doing great. I'm doing great.
Awesome, man. I'm at this system, and for some reason the low voltage fuse, which is a 3 amp fuse, keeps blowing. Checked all my wiring, I don't see any rub outs, nothing's touching, everything looks good to me. I'm just kind of...
We're blowing the fuse for a reason.
Right.
What components are tied into it?
I have my pan switch and my secondary float switch.
It's just the 2 switches?
2 switches, yes.
Okay, one thing we could do is we could put an ohmmeter on each of the switches individually to see if there's a high resistance on the switches, or we could turn around and take each one of them out of the circuit one at a time. We're going to lose a fuse or two that way, but...
Yeah. No, I've actually already taken the switches out one at a time, isolated them. It's just a normal. It's a heat pump, so I've got the reversing valve and just going to the thermostat like normal.
Okay. So you've got the reversing valve in there, the reversing valve relay in there.
Mm-hmm.
Anything with the thermostat? Have you checked the wiring at the thermostat to make sure that there's nothing shorted in there?
Yes, I have.
So you've ohmed out all your wiring and everything.
Yeah.
About the best we can do is to go through and check everything one at a time, because it's either got to be wiring or it's got to be one of the devices that's pulling an excessive current when it tries to engage.
Okay. What about the? Do you think I should check the amperage on each wire?
Well, you could put depending upon what kind of a meter you're using, you can use a fluke that'll go up to 10 amps.
I'm just using the regular compact filled piece, but it has an amp clamp on it. So.
Okay. It's just 3 amps kind of far down on the scale, so it may be a little hard to catch it.
Okay.
Have you made sure that there are no loose connections on any of the commons or anything like that?
Yeah.
24 volts?
Mm-hmm. Yes, this is a 24 volt application. Yeah, I've made sure everything's tight. Like I said, no skint wires, nothing's rubbing or anything.
Is there one of the secondary wires that goes to ground off the transformer?
No.
Okay, so we got a floating secondary.
Mm-hmm. That was going to be my next step, was to check the amperage.
How many fuses have you put in?
2.
Okay, so chances are you're actually seeing that kind of an amperage. I mean, you can check it, but if it's popping them relatively quickly, it's gonna go quick. If you've got a max capture on the meter, you can use that. It'll show you where it actually blows at. But it sounds like we've got a short, or is it blowing the fuse with nothing pulling in, like a contactor or anything like that?
Well, I just checked the amperage on the all the wires, and on my yellow wire, I actually got around 6 amps.
You got 6 amps on the yellow wire.
Yep.
So that's most likely going to be going to your compressor contactor.
Right.
So I just want to clarify one thing real quick. What we did, Mike was right. Using a compact meter like any your regular multimeter, trying to amp out one of the wires, if you've got an immediate fuse blowing, that's not going to really do much good, because it's going to blow so quickly. You're not going to really be able to read whatever minimal amps you're going to get. It might be too quick. So what we should have done was told Mike that what we did was we came to the thermostat, we put a little popper or some sort of resettable fuse inside the air handler, and we disengaged each individual wire and jumpered each one individually to red, and then until we finally got the fuse to reset or to blow. So that would have been a much better way and more practical way in the field to be able to isolate which circuit has the short. And of course, if we did this and we had the issue that we were talking about, a shunted coil, if as soon as we jumpered yellow to red and then we reset power, that would immediately trip the fuse, and we would know that on this circuit, the Y circuit, is our issue. Just wanted to clarify that. That's something that we should have done. Mike from Bluon was absolutely correct in the way that he explained things. We were a little off in the way that we attacked the problem.
Have you look at your compressor contactor and see if you've got a contactor that's hanging up that isn't allowed to pull all the way in, they will pull excessive current on the coil.
Okay.
What happens is it doesn't let the contactor pull all the way in to close that the magnetic area of the coil, and so it's holding way out, and so that will cause excessive current draw.
Okay.
So that's what I would look at. And in the case of a lot of those contactors, if they're not pulling in, you can sometimes open them up and clean them. But if it's pulling 6 amps, it's way over what it should be.
Right. Do you think maybe I should ohm the contactor out?
I don't think ohming is going to show you anything, because it's the magnetic field and not being able to pull the contactor in, pulling the really high current.
Okay, why is that?
Well, have you ever worked with a solenoid and plugged the solenoid in, put voltage through the solenoid without the solenoid on the solenoid valve?
Yes, I have.
What happened? You burn up the coil.
Yeah.
It's because it's looking for that magnetic.
Yeah.
So I would say that it's in that coil that's not being allowed to pull in all the way. So, I mean, I would look at the contactor mechanically. You can't ohm it.
Right, and what happens if it ohms pretty low, though? Like, I'm getting about at 1.5 ohms.
Well, you'd have to compare it to a good one to see what the good one is running.
Yeah,
Because, I mean,
I have a couple more on my van, and I compared them to that, and I'm getting about, so I got 1.5 on this one, but on those, the good ones, I'm getting around 7.5.
Well, if you've got that kind of a deviation, then I would say change the contactor, and then you may have something, a turn-to-turn short inside the coil.
Okay. All right. Well, I appreciate it, Mike.
Not a problem.
All right. Thank you, sir.
Have a great one. Thanks
You
for
do.
calling
You
us.
too. You have a great day.
All right. Bye-bye.
Bye-bye.